Lenses are the stem of photographer's kit. All the amazing photos we take or see can be attributed to lenses somehow. There are primarily two types of lenses: variable focal length and fixed focal length. We'll talk about the focal length in details in the basic concept section, but it essentially tells us how wide the frame could be. It is measured in millimeters. Let's talk about fixed focal length, or also called prime lenses. These lenses are great for a lot of purposes. They have much better performance in low light due to their simple construction, and also prime lenses give better results than variable focal length lenses of similar focal length. We highly recommend everyone to have a prime lens in their kit. Both Canon and Nikon have a 50mm prime lens, which is not expensive and is great for all beginner photographers. Generally, prime lenses are preferred by professional photographers who are more inclined towards quality of the image and know exactly what they want to capture. The variable focal length lenses are bigger and have mechanical parts to move the lens from one focal length to other. The image quality might be less than prime lenses, but for everyday use they work just fine. For beginners, the zoom lenses are much better as they give more flexibility for framing and composition. Now let's see which lens is good for you and your style of photography. If the focal length of the lens is between 8 to 24mm, which are also called fisheye lenses, they are great for wide panoramas, skyscapes, and artistic photography. These are so wide, they actually start to bend lines to accommodate them in the camera frame. The 24 to 35mm wide angle lenses are mostly used by photojournalists and street photographers as they provide a wide enough view which still looks realistic. The higher end of this range is also used for portraits, advertising, architectural, and similar kind of photography. The 35 to 70mm range can be called the standard lenses as they are great for travel and clicking photos of family and friends. The 70 to 105mm mild telephoto lenses are great for nature and portrait photography. The last range is 105 to 400mm, which are called telephoto and super telephoto lenses. These are primarily used for sports and wildlife photography. The last category is macro lenses. These can be of various focal lengths, but their main difference is the minimum focus distance, which is very much needed for macro shots. Let's talk about some important attributes of lenses. First is focal length. As discussed before, focal length determines the angle of view, which tells us which lens is good for which kind of photography. The second property that comes with every lens is the aperture range the lens supports. We'll talk about aperture in details in basic concept section. It essentially lets you know how much light it can let through to the sensor. The smaller value in the aperture range of the lens tells us the minimum aperture the lens can support, or the widest the opening could be of the lens to bring in more light. And more light means better exposure and better performance in low ambient light. This makes the lens faster, as we can use faster shutter speeds with such lenses. As we discussed in the image sensor lesson, there are many types of sensors. Let's talk about two most important ones: full frame sensors and APS-C sensors or crop sensors. All companies make lenses for both APS-C and full frame sensors. Lenses for APS-C sensor are smaller, lightweight, and capture area corresponding to a smaller APS-C sensor only. The other lenses for a full frame camera are bigger and a little heavier because they have to cover a bigger sensor size. Now, as shown here, these are the views of a full frame and an APS-C lens. When they are attached to a camera, this is what actually is captured by the respective sensors. Notice the area shown in black between the green and yellow rectangles that the APS-C sensor has not covered. This is why the APS-C sensor is known as the crop sensor. Each crop sensor comes with a specification called the crop factor, which tells us the amount of area cropped due to the smaller sensor size as compared to the full frame sensor. In most APS-C cameras, the crop factor is 1.5x, which means that the sensor records images 1.5 times smaller than a full frame sensor. Now, there are 4 scenarios as shown here. An APS-C sensor with an APS-C lens would work just fine. Next, a full-frame sensor with a full-frame lens would also work fine. When we pair a full-frame lens with an APS-C sensor, the image circle casted on the sensor is much bigger than the sensor. So the sensor just captures the photo corresponding to its own size. What this means is that if you use a full-frame 24mm wide-angle lens with your APS-C sensor camera, it will crop a lot of picture, about 2/3 of it, to fit the APS-C sensor size. This will be effectively a 1.5x crop factor and would be equivalent to using a 36mm full-frame lens with a full-frame sensor size. In other words, a 24mm full-frame lens on a APS-C sensor is equivalent to a 36mm full-frame lens on a full-frame sensor. Now, when we use a APS-C lens with a full-frame sensor, the image circle cast on the lens is much smaller than required to capture a full-frame image. That's why in all full-frame cameras, if you use a APS-C lens, the camera automatically switches to a smaller APS-C crop mode. Most lenses these days come with something known as the autofocus motor. This helps the camera to mechanically move the lens to focus properly. Also, most semi-professional or professional cameras have this autofocus motor built in the camera body as well. This is because there are some lenses which do not have this motor, so the motor in the camera can drive the autofocus function. Now, if your camera or the lens are missing this autofocus motor, the only option you would have is to focus manually. Some lenses are built in with an image stabilization system, also called vibration reduction system, which helps the camera to compensate for small hand or camera movement, especially during low shutter speeds. There are two kinds of stabilizations, optical and digital. Optical stabilization is much better as the lens actually adjusts itself to counter the hand movements, but the image quality remains the same. But in a digital stabilization, the image is corrected after it's being captured, so there might be loss in quality. Now, let's see how to change lens in a Nikon and a Canon camera. On both the lens and the camera body, there are markings where the lens would attach perfectly. Just align the lens and the camera markings and rotate till you hear a click. Similarly, in a Canon camera also, you will find these markings easily. Do not try to push the lens in or rotate the lens to find the grooves to fit, as this can damage the connector. That's it from lenses. We'll see you in the next video.